On a cold December night, 330 million kilometers from the Sun, the most powerful telescope humanity has ever built turned its mirrors toward a fragment of ice that should not exist. It had no business being there. It was not born in our solar system. It did not orbit our sun by birthright. It had crossed the galaxy for longer than the sun itself has burned. And now, for a few fleeting weeks, it was close enough for James Webb to look directly into its chemistry and read the story written inside it. What the telescope found did not just surprise the scientists watching. It rewrote what they thought they knew about where comets come from, how old the universe's wandering debris can be, and why this particular visitor refuses to behave like anything we have cataloged before. And by the time the data finished processing, one Harvard astrophysicist was on national television asking the question nobody in mainstream astronomy wanted to say out loud. Its name is 3I Atlas. The I stands for Interstellar, and the number 3 tells you everything about how rare this is. In the entire recorded history of astronomy, only 3 objects have ever been confirmed to have originated outside our solar system. The first was Oumuamua in 2017, a strange elongated rock that tumbled through our neighborhood so briefly that scientists barely had time to point their instruments at it before it vanished. The second was Comet Borisov in 2019, a more conventional icy visitor that at least behaved like something astronomers recognized. Then, in the summer of 2025, the Atlas Survey System, a network of automated telescopes built to hunt for asteroids that might threaten Earth, caught a faint smudge of light moving in a way nothing native to our solar system moves. It was not orbiting the sun. It was passing through on a trajectory so fast and so straight that only one explanation fit. It had come from somewhere else, somewhere outside, and it was never going to stop. For months, 3I Atlas was just a curiosity, a faint object crawling toward the inner solar system, tracked by observatories around the world as it approached its closest pass to the sun in late October 2025. Astronomers knew this was a once-in-a-research career opportunity. Interstellar objects do not return. There is no second chance to study them, no follow-up mission, no waiting for a better alignment next year. Whatever data could be gathered had to be gathered now, before the object slipped past the sun and began its long, irreversible journey back into the dark between the stars, gone forever. Consider what that actually means for the people who study the sky for a living. A planetary geologist can wait a decade for the right funding cycle to send a probe to Mars. An exoplanet hunter can simply keep watching the same star for years, refining measurements a little at a time. But an interstellar object offers none of that patience. It arrives uninvited, on a trajectory dictated entirely by the physics of its journey through the galaxy, indifferent to human budgets, launch windows, or telescope scheduling committees. It does not orbit anything. It is simply passing through, borrowing the sun's gravity for a brief detour before continuing on a path that will carry it back into interstellar space forever. Every observation of 3I Atlas, from the moment it was first flagged by the automated detection algorithms of the Atlas survey to the final data Webb managed to squeeze out of it before it faded from reach, existed inside a closing window measured in months, not years. Astronomers were not studying this object so much as racing it. So when 3I Atlas swung around the sun and began heading back outward in December 2025, freshly heated, its ancient ice suddenly boiling into a glowing cloud of gas, astronomers did something remarkable. They interrupted the carefully planned schedule of the James Webb Space Telescope, one of the most oversubscribed scientific instruments ever built, competed for by thousands of researchers across the planet, and redirected it toward this one fleeting target. It was a gamble. Webb had a narrow window. The comet was moving away, cooling, fading. If the telescope missed its chance, there would be no second attempt. It did not miss. Using an instrument called NIR-SPEC, a near-infrared spectrograph capable of splitting the faint light coming off the comet into a detailed chemical fingerprint, Webb captured something researchers were not prepared for. The comet's coma, that glowing halo of gas boiling off its surface, contained an unusually high concentration of deuterium, sometimes called heavy hydrogen. Ordinary hydrogen is the simplest atom in the universe, a single proton paired with a single electron. Deuterium carries an extra neutron in its nucleus, making it heavier, rarer, and in the context of a forming solar system, a kind of chemical fossil. The ratio of deuterium to ordinary hydrogen found in comet ice tells scientists something about the temperature and radiation environment the object formed in, billions of years before anyone was around to witness it. And the ratio inside 3I Atlas was not just elevated. It was nearly 30 times higher than anything ever measured in a comet native to our own solar system. 30 times. To put that number in context, every comet astronomers have ever studied up close, Halley, Hale-Bopp, Churyumov, Gerasimenko, the ones visited by spacecraft and picked apart atom by atom, carries a deuterium signature within a fairly narrow, predictable range, because they all form from the same disk of material that eventually became our sun and planets. 3I Atlas shattered that range entirely. Whatever cloud of gas and dust this object condensed from, it was colder, more radiation-soaked, and utterly disconnected from the chemistry that built our own cosmic neighborhood. Researchers began working backward. If an object carries this much heavy hydrogen, and this little of an isotope called carbon-13 relative to ordinary carbon-12, what kind of environment does that require? The team, led by astrochemist Martin Cordner at NASA's Goddard Space Flight Center, concluded that 3I Atlas most likely formed in a cold, dense molecular cloud, exposed to significant radiation early on, but never afterward warmed enough to reprocess that heavy water back into anything resembling the ice we know. It had been frozen, essentially undisturbed, since a time before our sun had even ignited. And then came the number that turned a fascinating discovery into a genuine sensation across the scientific world. Based on the isotope ratios, the team estimated that 3I Atlas could be somewhere between 10 and 12 billion years old. Let that sit for a moment. Our solar system, our sun, our Earth, everything you have ever known, is roughly 4.6 billion years old. This fragment of ice, drifting silently past our planet, had already existed for more than twice that span, before our sun had even condensed out of its own birth cloud. It formed during an era astronomers call cosmic noon, a period roughly 10 billion years ago when star formation across the universe was at its most furious peak. Galaxies were colliding and merging at a pace they never would again. And the raw material for planets, stars, and eventually life was being cooked in environments almost unimaginably different from our own quiet corner of the Milky Way. This object is older than the sun that is currently warming it for the first and only time in its billion-year existence. The paper detailing these findings was published in the journal Nature in late June 2026, and it was not the only team chasing 3I Atlas's secrets. A separate group, using the European Southern Observatory's Very Large Telescope, led by astronomer Cyrielle Opitom, examined the comet's carbon and nitrogen chemistry through a compound called cyanide, complementing Webb's findings and reinforcing the picture of an object built from fundamentally different ingredients than anything in our solar system. Stephanie Milam, a co-author on the research from NASA Goddard, put it in stark terms. So far, she said, we know of only one place in the vast cosmos where the chemical ingredients came together to produce life. Our solar system, our Earth. Studying interstellar objects like this one is a step toward understanding just how rare, or how common, those conditions might actually be scattered across the galaxy. But the deuterium discovery was only the beginning. As 3I Atlas continued its retreat from the sun, drifting further into the cold in mid and late December 2025, Webb turned a different instrument its way. This time it was MIRI, the mid-infrared instrument, capable of capturing an entirely different slice of the comet's chemical fingerprint. The observations, taken on two separate dates, December 15th and 16th, and again on December 27th, as the comet drifted from roughly 330 million kilometers to nearly 380 million kilometers from the sun, revealed something the European Space Agency later described, almost playfully, as the comet having sniffed methane. It was not a small trace. The methane detected relative to water was significantly higher than what astronomers typically find in solar system comets. Combined with the earlier confirmation that 3I Atlas was releasing an unusually large amount of carbon dioxide relative to water, again, far exceeding typical solar system ratios, the picture solidified. This was not simply an old comet. It was a chemically alien one. Every measurement Webb took pointed toward a formation environment utterly disconnected from the processes that built the planets we live among. There was something else buried in the mid-infrared data, too. As the comet moved further from the sun and cooled, its gas production dropped off sharply, but not evenly. Water, the least volatile of the three major gases, shut off first and most dramatically as the surface temperature fell. Methane and carbon dioxide, more volatile, persisted longer, concentrated closer to the nucleus itself, while water vapor spread in a much wider halo, released gradually from icy grains scattered throughout the coma. It was, in effect, a slow-motion snapshot of an ancient body losing its breath as it retreated back into darkness, each gas shutting down according to its own physical rules, like watching a dying star's layers peel away one at a time. Scientists at NASA described this as the telescope's first mid-infrared chemical fingerprint ever captured of an interstellar object, a genuine milestone, regardless of what 3I Atlas turns out to be. And the timeline of this object's journey through our solar system, once mapped out fully, only deepened the sense that we were watching something extraordinary and fleeting. Discovered in the summer of 2025 by the Atlas Survey, observed by India's ISRO and the Physical Research Laboratory in November 2025 using the infrared telescope at Mount Abu, a rare and proud contribution from Indian astronomers to the global effort tracking this visitor. Perihelion, its closest approach to the Sun on October 29th and 30th, 2025, passing just inside the orbit of Mars. Then, in March 2026, a flyby past Jupiter, the solar system's largest planet briefly tugging at the trajectory of an object that had already crossed unimaginable distances to get here. At no point did 3I Atlas ever pose any threat to Earth. Its closest approach to our planet was never less than roughly 1.8 astronomical units, something in the range of 270 million kilometers, a comfortable, uneventful distance. This was never a story about danger. It was always a story about origin. And that is precisely where things got complicated, because extraordinary data invites extraordinary questions, and not everyone in the scientific community was content to file this away as simply an old, chemically unusual comet. On June 24, 2026, Harvard astrophysicist Avi Loeb, head of the Galileo Project, an initiative explicitly dedicated to searching for evidence of extraterrestrial technology, appeared on News Nation and referenced the elevated methane levels detected in 3I Atlas. His question was blunt, and it rippled across the internet within hours. Was it possible, he asked, that what Webb was detecting was not simply chemical outgassing from ancient ice, but something indicative of microbial activity locked inside this frozen relic? Loeb has built a career and a considerable amount of controversy around exactly this kind of provocation, having previously suggested that Oumuamua itself might have been an artificial object, a piece of alien technology rather than a natural rock. His willingness to ask the uncomfortable question, the one most career astronomers avoid for fear of ridicule, is precisely what makes him either a visionary, ahead of his colleagues, or a headline-chasing outlier, depending entirely on who you ask. The mainstream scientific response was immediate and largely unified. NASA's own findings, and the overwhelming majority of astronomers studying the data, maintained that the elevated methane and carbon dioxide levels were the result of entirely natural thermal outgassing, ancient ice reacting predictably to the heat of a close solar passage. Nothing more exotic than that. But Loeb's comments had already done what they were designed to do. They reopened a question that has quietly haunted every interstellar object discovery since Oumuamua first tumbled through our skies in 2017. What if one day one of these visitors turns out to be something built rather than something formed? That question was serious enough that it triggered an actual formal search. The SETI Institute, in partnership with the Breakthrough Listen initiative, one of the most well-funded and scientifically rigorous efforts ever assembled to search for signs of extraterrestrial intelligence, turned the Allen telescope array toward 3I Atlas to listen. Not metaphorically, literally. Radio astronomers combed through nearly 74 million individual radio signals gathered during the observation campaign, searching for anything that might indicate an artificial transmitter rather than natural background noise. Of those 74 million signals, 211 candidates survived the initial filtering process, rare enough to warrant closer scrutiny. Every single one was ultimately traced back to human technology, satellites, ground-based interference, the ordinary electromagnetic clutter of a species that has filled its own sky with machines. According to the study, published by researcher Sophia Sheikh and colleagues in the Astronomical Journal, the search conclusively ruled out the presence of any artificial transmitter on 3I Atlas stronger than somewhere between 10 and 110 watts, a sensitivity threshold precise enough to catch almost anything short of complete radio silence. So, no beacon, no transmission, no confirmed signature of anything built rather than born from ice and radiation over 10 billion years. The scientific consensus, as it stands today, remains firm. 3I Atlas is a comet, an extraordinarily old, chemically alien, scientifically unprecedented comet, but a comet nonetheless, obeying the same physics that governs every other frozen wanderer that has ever crossed a star's gravity well. Still, it is worth understanding why Avi Loeb's question carried the weight it did, rather than simply being dismissed as noise. Loeb is not a fringe figure shouting from the internet's outer edges. He spent nearly a decade chairing Harvard University's astronomy department, one of the most respected positions in the entire field, and his academic record includes hundreds of peer-reviewed papers on black holes, the early universe, and the formation of the first stars. When Oumuamua tumbled through our solar system in 2017, exhibiting a strange, unexplained acceleration as it left, an acceleration that did not match the behavior of any known comet or asteroid, Loeb was among the first to suggest, seriously and in print, that the object might be artificial, perhaps a discarded fragment of alien technology, a solar sail drifting dead through the galaxy. Most of his colleagues disagreed, and the eventual explanation offered by mainstream astronomy involved outgassing from hidden pockets of frozen hydrogen, a natural, if unusual, mechanism. But the disagreement itself became a kind of permanent fixture in the field. Every interstellar object discovered since has been quietly measured against that same unresolved argument. Is this one natural too? And every time, so far, the answer has come back in yes. Yet the fact that serious scientists feel obligated to check To actually point radio telescopes at these objects and listen, rather than simply assuming, tells you something important about how genuinely strange these visitors are. They do not behave enough like ordinary solar system objects to be dismissed without investigation. They earn the scrutiny. There's also the matter of scale that rarely makes it into the headlines. The Allen Telescope Array, the instrument used to scan 3i Atlas for artificial signals, is itself a monument to exactly this kind of long-shot vigilance, a field of dishes in rural California built specifically because the scientific community decided the search for intelligent signals was worth funding seriously, decade after decade, even when the odds of success on any single target are vanishingly small. Sifting through 74 million signals and finding 211 candidates worth a second look is not a trivial undertaking. It requires filtering out the electromagnetic fingerprint of an entire planet's worth of satellites, cell towers, radar installations, and orbital debris, all of it humming away in the same frequency ranges. Astronomers must search for anything genuinely foreign. That every one of those candidates eventually traced back to something human-made is, in its own way, a remarkable achievement of precision, not a disappointing null result. It means the tools worked exactly as intended. It means that if 3i Atlas had been broadcasting anything above roughly 10 watts, less power than a household light bulb, spread across the entire radio spectrum, we would very likely know by now. And yet, the questions this object raised are not fully closed, and perhaps they never entirely will be. Because the deeper truth sitting underneath all of this is not really about whether 3i Atlas is artificial. It almost certainly is not. The deeper truth is about what its mere existence tells us about everything we don't yet know. Here is an object that formed roughly 10 to 12 billion years ago during an epoch of the universe so violent and so productive in star formation that astronomers call it cosmic noon, a phrase that almost sounds poetic until you realize it is simply describing the era when the universe was building the raw material for essentially everything that exists today, including, eventually, us. This object drifted, frozen and untouched, through the emptiness between stars for longer than our entire solar system has existed, carrying inside its ice a chemical memory of conditions no human instrument has ever directly sampled before. And then, for a handful of weeks in late 2025 and early 2026, it happened to pass close enough to our small, unremarkable star that the most sophisticated telescope our species has ever built could finally read that memory. If 3i Atlas had arrived 1,000 years earlier, or 1,000 years later, no one would have seen it. If James Webb had not existed, if NIRSpec and MIRI had not been engineered with the precision required to detect isotope ratios and trace gases at 300 million kilometers of distance, this object would have swept past the sun in total scientific silence, its 10 billion-year-old secrets undetected, unread, gone again into the dark before anyone even knew to look. That is the part of this story that tends to get lost beneath the alien speculation and the viral headlines. Not that we might have found evidence of something built by another civilization. We didn't. What we actually found may be even stranger, in its own quiet way. Proof that the universe has been quietly manufacturing objects like this, ancient, alien in composition, utterly indifferent to the existence of stars like ours, for the entirety of cosmic history, and that every so often, purely by chance, one of them threads a path close enough for us to notice. How many others have passed silently through our solar system before humanity had telescopes capable of detecting them? How many crossed paths with early Earth, with the dinosaurs, with whatever existed here before there was anyone to look up? And how many more are out there right now, tumbling through the space between stars, carrying fragments of a universe 10 billion years younger than the one we currently inhabit, waiting for the right century, the right telescope, the right astronomer, willing to interrupt a carefully planned observation schedule to catch them before they vanish again? 3i Atlas is gone now, or as good as gone, magnitude 15 and fading, well beyond the reach of any telescope smaller than the world's most advanced observatories, invisible to the naked eye, invisible even to most backyard instruments, and it was never going to be seen that way regardless. It is currently somewhere beyond the orbit of Jupiter, accelerating outward on a trajectory that will carry it back into interstellar space permanently. It will never return to our solar system. Not in 100 years, not in 10,000, not ever. Whatever else scientists manage to extract from the data already gathered, and researchers are still combing through it, still publishing new findings, still arguing over what the isotope ratios truly mean, this is essentially the last chapter of direct observation. This object will ever offer humanity. Somewhere out beyond the edge of what our telescopes can reach, 3i Atlas continues its journey, carrying with it a chemical signature 10 billion years in the making, the third confirmed messenger from beyond our solar system in all of recorded human history, and almost certainly not the last. Because if one comet, born during the universe's most violent era of star formation, could drift undetected for that long before finally crossing our path, then somewhere out there, right now, moving through the dark between the stars, there are others. And the only question that remains, the one no team of scientists, no spectrograph, no radio array has yet been able to answer, is which one we will catch sight of next, and what it will be carrying when we finally do.